So, you're a Python developer. You love the speed of getting things done, but you've heard the stories, right? You're craving that raw performance, that low-level control of C++. Well, you're in the right place. In the next few minutes, we're going to take everything you already know from Python and translate it into your first steps with C++. Let's do this.
Here's our game plan. First, we're going to talk about the big mindset shift you need to make. Then, we'll get our hands dirty and write some code. After that, we tackle the number one thing that trips up Python folks: types. Then we'll see how your existing logic skills fit right in, how to organize your code, and finally, we'll get a little peek at what makes C++ so ridiculously powerful.
All right, so what's the real difference here? Honestly, it's not the semicolons or the curly braces. It's the entire philosophy. Python and C++ come at the problem of programming from completely opposite ends of the field, and once you get this, everything else clicks into place.
Okay, think of it like this. Python is like having a live human interpreter. You say a line, they translate it and execute it. You say the next line, they do the same. It's super flexible. You can change things on the fly. C++, on the other hand, is a factory. You give it the entire blueprint for a car. The factory takes that blueprint, builds the whole car, optimizes every single part for speed, and then hands you the keys to a finished, high-performance machine. It's more work up front, but the result is pure speed.
Enough talk, let's actually make something. You know that in Python, hello world is just one line. In C++, it looks like there's a bit more stuff, but don't let it intimidate you. Every single piece of this is there for a very specific reason.
Let's just tear it apart. That #include line, that's just import. You're grabbing a toolbox for handling input and output. Simple. Every single C++ program on the planet has to have a main function. That's just the official front door. stdcout, that's just a fancy way of saying print. And return 0, that's you giving a thumbs up to the operating system, telling it, hey, we're done here and everything went great. See, it's a predictable pattern.
So, a few new rules of the road. We already talked about #include for importing. Next up, those curly braces. They are your new indentation. They define where a block of code begins and ends. That stdii thing just tells the compiler where to find a tool, in this case, the standard tools. And this last one, oh boy, the semicolon. Nearly every single line has to end with one. You will forget it and the compiler will yell at you, but soon it'll be pure muscle memory, I promise.
Okay, deep breath. This right here is the biggest change, the most important new idea you need to wrap your head around. It's called static typing. It might feel a bit like handcuffs at first, but it's actually the secret ingredient to C++'s incredible speed and safety. So in C++, a variable is like a box that's been built for a very specific purpose. Before you use it, you have to label it. You have to say, this box is only for integers, or this box is only for strings of text. And once you've put that label on, that's it. It's locked in forever.
And here's why that matters. In Python, you can have a variable x, give it a number, and then later on decide, you know what, now it's going to be a string. Python just shrugs and says, okay. Try that in C++, and the compiler, our factory foreman, will slam on the brakes and shout, no way, you said x was an int box, and you were trying to stuff a string in it. This catches so many bugs before your program even gets a chance to run.
Okay, you survived static typing. Now for the really good news. You already know how to do all the hard stuff. All of the logic, if this, then that, loops, all of it works exactly the same way you're used to. You just need to learn a few new punctuation rules. For your if-else statements, it's super simple. The question you're asking, like age greater than or equal to 18, has to go inside parentheses. And the code you want to run, that goes inside those curly braces. That's it. No more counting spaces or hitting the tab key. Now, the C-style for loop looks a bit scary, I get it, but it's actually just 3 little instructions in one line. First part, where do we start our count? Second part, what's the rule to keep going? And the third part, what do we do after each time through the loop? It's just start, condition, and increment. Super logical once you see it. So, we can write commands, we can write loops, but how do we organize everything? Well, you know how in Python you're always using lists to hold stuff? C++ has something that's going to feel very familiar.
If you're missing your Python list, don't worry. Say hello to std vector. It is, for all intents and purposes, your new go-to. It's a list that can grow and shrink whenever you need it to, and you're going to use it all the time.
And just look how similar they are. Instead of .append,
You use .pushback. Okay, a different name, but same idea. Accessing an item with the square brackets? Exactly the same. And check this out. The modern C++ way to loop over it looks almost identical to Python's for-item in my list. It's really easy to get used to.
Okay, so what about organizing our actions? Well, we've got functions and classes, just like Python. The only catch is, because of static typing, you have to be upfront. You have to say what kind of data a function returns and what kind of data it takes in. And with classes, you get these cool keywords, public and private. Think of public as all the buttons on the outside of a machine that anyone can use, and private as the delicate wiring inside that you don't want people messing with. It's all about safety.
We've zipped through the basics, but before we go, I want to give you a quick glimpse into the real power of C++, the stuff that lets people build massive, complex things like operating systems and game engines. It's a concept called inheritance.
So check this out. Let's say we make a class for a basic dog, a hund. It has a bellin method to bark. Now say we need a special kind of dog, a police dog or police hund. We don't have to start over. We can just say that a police hund is a hund. It gets all the normal dog stuff for free. But then we can add new, special abilities, like fest schnappen. We can even change, or override, the original bark to make it sound more serious. This is how you build complex systems without rewriting code all the time.
This idea of overriding methods leads to something with a fancy name, polymorphism. All it really means is that you can treat a whole group of different objects the same way, and they'll each know how to do the right thing. You can tell a list of animals to make sound, and the dog will bark, the cat will meow, and the police dog will use its special bark. That flexibility is the magic that makes huge, complex applications possible.
And there you have it, your 5-minute crash course translating Python into the world of C++. You've seen the difference between interpreting and compiling, you've conquered static types, and you've had a taste of object-oriented power. The first, hardest step is officially done. So the only question left is, what are you going to build with all